Welcome to Final. This video is made to familiarize and train you for the busy atmosphere of vectors to Copenhagen. Final is the most critical position you can sit at for VTC because if your flow breaks down, it draws a line of chaos all the way out to even our neighboring countries. Controlling Final is relatively easy. It requires though that you absolutely master 3 different aspects. If you achieve this, you will have a great time on Final. These 3 different aspects are: first, you have to be able to manage all distractions. You cannot fall behind, so you must be extremely good at first of all anticipating and also be ahead of when different instruction needs to be given. That's why it's good to have a solid structure and know exactly what instructions are needed when. Think of this as being your square. You always gotta know what goes on within this square and always know exactly what the next step is and when it is. And that's why we're also going to talk about different times that you can do the different instructions in order to always be ahead of the flow. Altitude, speed, headings, tower frequencies, all these things you have to be really precise on. You don't try anything else unless you really have the time. You just got to keep yourself focused in your box. Next thing is speed. Your speed control must be perfect and in line with what I'm going to tell you here in this presentation, as well as also the third thing, choosing just the right time to turn base, and even also timing it in a way that it gives you the most overview. All these 3 things we're gonna go back to in a bit. So first we need to get the definition out of the way. What are your base values? When you're sitting on final, it means that you're sitting during periods of reduced separation procedure. First of all, what the heck does that mean? It means doing normal operation, we aim for 5 nautical miles of separation, but no less than 3 miles before heading over. This can be very inefficient during large events where we need to have 40 plus airplanes on the ground every hour. With reduced separation, we can aim for 3 miles separation and then we have a buffer to go all the way down to 2.5 miles. And actually even all the way down to 2 miles just before landing because, quote, quote, tower controller can visually see airplanes and we assume he can do that. One of the things you need to understand on final as well is the all-important mathematical side to it. We are all, from you to ACC, counting on sequencing in 40 airplanes per hour. That means ACC Copenhagen is funneling in, alongside Sweden Control, 20 airplanes every hour into the approach sector. That's 1 airplane every 3 minutes. The approach controller will then merge them from all the different directions, form a nice line into your airspace with 1 airplane every 3 minutes, which is normally about 10 to 12 miles. You now need to take these airplanes and merge them in a way so that you have an average an airplane every minute and a half. Now, how does that compare to miles? Because we are getting people in on other frequencies in minutes, but you need to be dealing in miles. An airplane every minute and a half, that's an airplane every 4 miles. This means if you have a 10-mile long final, every time you sequence 2 airplanes with less than 4 miles, your final will get smaller. Every time you sequence 2 airplanes with more than 4 miles, your final gets longer. It's just the mathematical fact. Imagine that if you have a 10-mile final like here, and then you do a miscalculation and you get 7 miles between 2 flights, well, your final is now 13 miles long. So the next 3 airplanes, you will have to get a really sharp 3-mile separation between them in order to get it back down. The point in all this is you have to be sharp as a knife in getting these airplanes in on a string, preferably with 3 miles between each, but no more than 4 if you can avoid it. Because more than 4 miles, then you will get flights to the tower controller at a slower rate than the approach controller gives them to you, and that will back you up. Now, how do you do this? It's very little separation, 3 to 4 miles, and it means first lessons. Things goes very fast and you have to be ahead of the flow at all times. You cannot get caught up in a specific flight that gives you trouble. This is a lesson that can be given without even looking at the scope, and I cannot stress this enough. You cannot ever fall behind on final. If you miss an airplane or the pilot doesn't turn as he needs to, just don't dwell on him. Don't dedicate extra attention to him. Don't try to put him back into your sequence. Give him a vector back to approach and then move on to the next airplane so you can always have these sharp 4 miles. Do not accept that one difficult airplane just breaking down your sequence. If something goes wrong, send him back to approach for resequencing. Don't play the hero and try to fix it yourself. It makes everything worse for you and everybody else. Remember your goal. It's about having 4 miles on average at the most between every airplane. Doesn't matter what airplane, but as long as you have that, you are doing fine and the flow will fit. Be ruthless. A bad pilot goes back to approach. An out of sequence flight, go back to approach. An improper separated airplane, go back to approach. You must expect tidiness in order to be successful with this high rate. Bringing us to the next two lessons, which basically can be combined as structure. You must have the correct structure, and these are the guidelines I would like to give to you. It is in regards to how to handle speed and how to handle the turns to base. Here is the final for 2 to left, which is the most regular being used. Let's assume a normal day with regular wind. You should get all the airplanes from approach at 220 knots and cleared to 4,000 feet. By the way, hold approach accountable, make sure these airplanes come properly separated with the correct speed. If not, send one back. Now, I need to deflate a myth. Slower is not better. You will have a long stream of airplanes coming in, and slowing them down too early will back everybody up behind you, and it will make it impossible for approach to keep the separation. Now let's look at why. Most often, it is when you want to see your final becoming longer, you feel like you start to lose overview, and like here for example, final is building up, airplanes coming in faster and faster, your first thought is slow him down, so he will not get that far out. But let's take a closer look at this. Be careful not to confuse miles with minutes, because you're still getting people in with a rate. You see, it doesn't matter what speed this guy's at, because that has nothing to do with when he gets in. It's all about this guy, the guy he's turning in behind. No matter what he flies, his arrival time is dictated by this guy. If this guy is arriving at, let's say, 1836, then he will be, let's say, 2 minutes behind, so 1838. The only difference with what speed is how many minutes until he needs to turn base in order to be 2 minutes behind the preceding. But the speed this guy's flying is actually what's important. Now keep this in mind as we just jump to another thing real quick. Remember, you get airplanes at a rate. This is converted to 10 to 12 miles, but it is based on 40 arrivals an hour, the rate we believe controllers with the skill of Denmark can realistically manage. 40 arrivals an hour is equivalent to approximately 4 miles between flights, meaning when you get 10 to 12 miles from approach, that's going to be 5 to 6 miles from each side. That means we're anticipating losing about 1 to 2 miles, sometimes 3, 1, 2, 3 miles of separation between airplanes that comes as a result of the speed reductions. But these does not take into account if you're reducing people before they're turning base. If you have 2 planes at 220 and reducing them on base, you're going to lose 1 to 2 miles. But the idea is not to lose separation of the downwind leg. If you already reduce him there when you get him, then the next up is going to catch up too fast. In fact, 10 miles at a speed difference between 180 and 220 means that this guy catches up by 3 miles by the time the first guy is turning base. Now comes the next guy, another couple of miles, next guy losing more miles, and so on and so forth. And you continuously slow everybody to 180 because, of course, you know your pace is dictated by the slowest guy in front. Now you need, as you turn this guy in at 12, to extend this guy to 14, next to 16, and suddenly you have an 18-mile final. You're probably thinking, well, that doesn't make any sense because I can just slow everybody to 180 when I get them, then they're all going to fly the same speed. Yes, but there's still planes coming from approach behind you, and they are now not going to be able to be handed over at this 10 to 12 miles. So now you will suddenly get flights at 6, 7, 8 miles in between, and then you also have a rate that doesn't work. Okay, now with this in mind, return now to the first picture, because we talked about that the pace is set by this guy. This 180 thing, it now hits you double as hard, because as he gets out to 18 miles with 180, he also needs to go all the way back to the ILS. 18 miles with that low speed, and because you will always have tailwind and downwind and headwind on final, now it will go even extra slow. So your delays will not just increase, it will be compounded. And at this point, you are done. Complete approach stop, wait the long wait for everybody to get in, and then, yeah, everybody's staying until midnight. Instead, keep 220 knots. Yes, you have less time, but that just means that what you need to train is to manage and avoid distractions so the 220 feels more comfortable. If it doesn't feel comfortable because airplanes are coming at a too high rate, less than the 10 to 12 miles, you just pop one in back to approach, so then you will have the space again. That's what you need to do. You need to keep up the speed. The higher the better, and you will see your final being kept down as a direct result of this. Then there's the next thing, the third lesson. Let's talk about the turn to base. You want to be aware of your separation. If you have a little bit too little separation when you turn base, you can make up for it by delaying the final turn. This is not dangerous. However, too much separation is very difficult to make up. So mark my word, really mark my word, do not hesitate with turning base. It is difficult to make up the ground once it's lost, and you will be surprised of how early you need to turn base in order to actually have the separation. So the solution to this is absolutely master the art of when to turn base. This you'll get through practice. However, here's some tools to help. Your aim is to have this 3-mile arrow from one aircraft to line up with the other aircraft as close as you can. That's your cue and what you need to look at when determining how and when to turn to get them beautifully lined up. There are basically 3 different kinds of base turns to use. The regular, which is 90 degrees on and intercept to final. The modified base, which is only halfway and then a direct turn onto final. Also possible is to use a mixture of a modified base and a regular base just for a short duration. That's also possible. Which ones to use depends a lot on the situation. Let's go through them. On a regular base, you wait until just the right moment to turn the airplane on an exact 90-degree base. This is simple, dependable, it's familiar, you've done it before, but it has downsides as well. On the modified base, you turn the aircraft only halfway towards the base, giving a sharper angle for the final turn, where a regular base for 2 to left would be heading 130, 310. A modified base would be something like heading east and north. The downside with this is that it is slightly more complex to manage and foresee, but it is compensated by the upside that it has a much wider array of places you can execute that from. And I will talk about that in a minute. The third option is a mixture. This is especially useful for flights on vectors further away where you combine them because you don't want to risk having to lose too much time on the base. But I want to return to this array of places you can execute the turn from because the most important thing is not to get behind, but to be ahead and proactive. And that is where the downside of the regular base sometimes comes in. Let's look a bit closer. Regular base, you have a relatively small window to make the turn. Too early and you will crash them into each other. So let's draw a red line to show that here you cannot turn the base in relation to the other airplane, because the flight will track directly towards one another. Now, as they get to here, at some point your window for turning base opens. What you want to aim for is, and this is very important, is for this guy to turn so that his edge of the 3-mile arrow is pointing directly to the next airplane. That gives you the most precise 3-mile separation. As the base turn goes on, he can now be turned in for a perfect 3-mile separation, and the closer he gets to the ILS, the more separation is actually going to be there in the end. So you can just judge this perfectly. Okay, so what if you don't hit that perfect mark, but you wait a bit longer? Well, there is a window. So as you turn him even slightly late, and you see that there's a kind of a gap opening up that you don't want, it's not too bad because you can, up to a certain degree, close that gap by turning him in earlier to close the gap. But it only works for a short while. At some point the window is closed and now you have too much separation and can't make it up, and your final gets longer. That's the downside. You have to turn them at just the right moment. Let's talk about modified base, because while it's a little more complex and more difficult to really anticipate, the upside with the modified base is that you can issue the turn a bit earlier because he will still be tracking outbound. This means as early as when the tip of the arrow is leveled with the preceding airplane's radar target, so the window opens earlier. And this is especially useful when you want to be ahead and not having to wait at that right moment, because then suddenly something else takes your capacity, and then you forget it. If your capacity allows for a base turn, but it's a little bit too early for regular base, you can use this modified base, and that's the way you always keep yourself ahead of the game. And please, 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 don't be afraid of turning inbound early. Remember the delay each pilot takes for the turn. This must be taken into account. Every time you set on final, Get more and more courageous in cutting down these margins, and always look at that 3 mile marker and turn before you see the required separation to anticipate that delay from the pilot. Let's take an example here from the scope. Red Nose 5-2 Yankee is getting the base turn, and you see he's not even level with the preceding yet. In fact, he's not even past him yet. We are anticipating so that when he turns, his 3 mile arrow is going to point the preceding aircraft. This is actually a direct screenshot from the moment the instruction was given. Now in this case, while it normally takes 4 to 5 seconds for the pilot to turn, here it takes actually almost 10 seconds before he starts his turn. That's longer than average, but let's see where he establishes on base. That's how it looks. See how much of a gap there are between the 3 mile arrow and the next aircraft. What you probably thought was too early of a turn has actually turned out to be a late turn. There's still one way to solve this, and it is to give Red Nose 5-2 Yankee an immediate right turn to intercept, so he makes up some of that lost ground. And this is exactly in this case what he gets, and he makes up as much lost ground as he possibly can on the way, and the rest we try to make up with the speed. Let's come back to the speed. In general, here are the recommended speed. 220 knots on downwind to be kept all the way until he starts the base turn. If you use less, the flow rate from approach will no longer fit and you have to change that with approach. And that's going to cause a ripple effect, and ACC has to transfer at a lower rate as well. Much easier is it just to learn to manage with 220 knots. It's not that difficult. As you give the base turn, the recommendation is reduced to 200. It's just a good all-round speed. It's so low that it gives you better time for the perfect intercept, yet so fast that it actually gives you the flexibility to make up ground because the preceding on the ILS will probably be flying 180. Also, at this 200 knot speed, most airplanes have flaps out, which helps them decelerate faster. One recommendation can be, if you have a lot of tailwind or headwind on the base, to reduce to 190 or speed up to 210 on the side that has the disadvantage. Then, now coming in on the final turn, the first thing you have to do is refrain yourself. Do not change the speed. Please do not change the speed. First, do the turn, let him make the turn to the intercept heading, and then see what you need. Do you see that they're more than 4 miles from each other? Then keep him at 200 because then they will make up some ground in regard to the preceding. As you turn them, are they just on the brink of 3 miles or are they even maybe a little bit below 3 miles? Slow them down. It's not a problem. Also, because they have the intercept, they are going to lose 0.2 miles, 0.3 miles extra as they do this intercept. Once they're on the ILS, then you can slow them to 180. The reduction from 200 to 180 though shall happen no later than 10 miles final. But I hope you see the idea in all this, that by keeping 200 you're allowing the airplane to catch up on the guy ahead of him on the ILS. Once you get them in and you have a separation you like, it can be somewhere between 3 to 4 miles, then you slow them down to 180 and you still have some margin to give until 160. As you sit more and more often on final, get more and more comfortable with really pushing those limits. Then, no later than 6 miles final, as per Doc 4444, you have to reduce them from 180 to 160 until 4 miles and hand them over to tower. So to summarize, 220 all the way until base. As you give the base turn, slow to 200. As you turn to final, keep the 200. Once on the ILS, slow to 180 once you are on the ILS or you're caught up to the aircraft in front of you by about 3 to 3.5 miles, then slow to 180. Just no later than 10 miles though. When ready to hand over, reduce to 160 until 4. Airplane behind will be 180 on the ILS at the same time, so then you allow them to catch up to those perfect 3 miles. That's it. Remember, 20 knots, it's 0.3 miles per minute, and they're 3 to 5 minutes away from landing, so it's not really that critical with these knots. It's only a tiny bit that catch up with each other. So don't get nervous. Try out your different limits. Push yourself to get this perfect 3 mile separation. Thanks for watching.